Could we extend life expectancy by 5 years with a calorie restriction, CR diet? While far from conclusive, there is growing evidence that a calorie restriction, CR diet could significantly extend both average and maximum lifespan, while reducing typical aging-related diseases. The trick is that it needs to be done over a significant time period and could be very difficult to achieve given typical overeating patterns. The ability of people to follow CR could be limited by feelings of increased hunger. The hope, however, is we could learn from the positive effects of CR on the body and then develop medicines that mimic these effects and give the same results. Calorie restriction involves reducing average daily caloric intake below what is typical or habitual without malnutrition or deprivation of essential nutrients. CR can be also accomplished by not eating at all for a period of hours or days, known as intermittent fasting, or by eating less at some or all meals. Researchers are exploring the theory that calorie restriction promotes a healthy lifespan by triggering changes in one or more biological pathways identified as playing a role in healthy aging. Biological pathways that work smoothly promote good health. Those that do not may contribute to disease and aging. Calorie restriction mimetics, mimicking the effects of CR research, is the search for potential therapies that target the same pathways affected by calorie restriction, with the goal of finding ways to extend how long people live in good health. According to a paper by the National Institute on Aging, scientists are working to discover what it is about calorie restriction that may help animals and humans stay healthy as we age. Researchers interested in calorie restriction mimetics focus mainly on 4 biological pathways. Insulin signaling pathway. When you eat, your body converts food into glucose, which is used for energy. Glucose in the bloodstream triggers the release of insulin, a hormone that determines whether the glucose is used immediately or stored. Impaired signaling along this pathway can lead to mismanagement of glucose and aging-related diseases like diabetes and heart disease. Mammalian target of rapamycin mTOR pathway. The mTOR pathway senses when nutrients are available. When it detects enough nutrients, it triggers cell growth. When it detects insufficient nutrients, which occurs with calorie restriction, the mTOR pathway triggers the cell's defenses against stress. This enhances the cell's ability to repair itself and to resist toxins and other challenges. Sirtuin-1, SART1 pathway. Sirtuins are a group of enzymes involved in metabolic regulation and cellular health. They can increase cellular production of mitochondria, the cell's powerhouses. SIRT1 is the most studied of the sirtuin group, and signaling along the SIRT1 pathway promotes the ability of cells to resist stress and to survive. AMPK pathway. AMPK is an enzyme that contributes to cell stability by triggering reactions that promote the efficient management of energy. With calorie restriction, activity is reduced along the insulin signaling and mTOR pathways and increased along the SIRT1 and AMPK pathways. Researchers are looking for compounds that have similar effects to reduce or increase activity. Someday, research could lead to the development of medicines that mimic calorie restriction's effects to slow the aging process. According to a paper in the National Library of Medicine, prolonged calorie restriction, CR, has been shown to extend the lifespan in a variety of lower species, such as yeast, worms, fish, rats, and mice. Calorie restriction, CR, a dietary intervention that is low in calories but maintains proper nutrition, is the only intervention known to date that consistently decreases the biological rate of aging and increases both average and maximum lifespan. So how much CR do we need to improve age-related health and possibly longevity? And how long do we need to sustain CR to obtain these benefits? It is estimated that a 5-year life extension could be induced by 20% CR, 20% fewer calories than normal, starting at age 25 and sustained for about 50 years. That intensity and onset of CR required to induce these effects is probably not suitable for many individuals. There is therefore a need for the search for treatments that mimic the biological effects of CR. If such medicines, such as resveratrol, prove viable in humans, individuals for the most part will opt to enjoy the effects of anti-aging via a pill rather than CR. Would you go on a CR diet if you thought it would let you live 5 years longer? Or are you the type to wait for a pill? Either way, we are learning more about the process of aging through the study of CR diets. Hopefully, this research will pay off in better health and longer life for everyone.